basics of data types. Okay. So let's see what we will discuss in today's session. So as I told you, we will discuss data types today. So we already have a basic idea on what are data types and why they are used. So we'll dive deeper into the data types and understand different data types that are there to represent data. Okay. And then we will see what are literals. If time permits, we will go a little further. Okay. Also, we will see some basic examples with those data types. Okay. So in our last session, we just discussed on a few of the questions that were posted by one of the participants, and we tried to cover all of those. So if you still have any doubts, you can always email your questions to okay. So intuition.javatraining@gmail.com. Please post your queries to this particular email ID. Okay. Okay. So let's get started with the session. So we have basic idea on what are data types, right? Data types is basically like how you store your data in your memory, and a particular type has to be associated to that that data, right? So what basically it shows is how much memory you need for storing that data, or in your main memory or otherwise, okay, while executing your program. That's what the data types are all about. So Java, it is said, it is a strongly typed language, in the sense like whatever the variables that you declare, whatever the expressions that you write, or whatever the parameters that you pass to a method, okay, or a function. We will see what are those methods and functions. So those parameters all will be evaluated, and they will be tested or verified for their compatibilities. Okay. So without that, you can't compile a Java file, in the sense like all should conform to the respective data types. Okay. So if you try to save a data like integer data in character data type, then you will get compile time errors. So all incompatible or mismatches related to types are considered as compile time errors, which must be corrected before you move ahead and execute your program. Okay. So as these are compilation time errors or compile time errors, you have to correct them in order to compile and generate your bytecode which can be executed. Okay. So Java defines, there are two kinds of data types here. So one is primitive data types, and others are objects. Okay, they are complex. Objects are called as complex data types. Okay, the primitive data types are like Java defines 8 primitive data types. Okay, they are different types, but they can be categorized into 4 groups. Okay, so what are those 4 groups? We have integers. Okay, these integers represent our whole numbers. Okay, integers represent our whole numbers. They are represented by 4 keywords, Java keywords. We know what are keywords, right? They are byte, short, int, and long. Okay, these are the 4 integers that we represent using these 4 Java keywords. Okay, byte, short, int, and long. Okay. They are used for your whole numbers, for holding your whole numbers, okay, without any fractional component, just whole numbers. Okay. Then we have another group, that is floating point numbers. Here we represent decimal numbers or your real numbers. Okay, real or fractional numbers or decimal numbers, which will have your decimal or fractional part associated with your number. Okay, it has two different types. One is float, another one is double. We will see what are these floats and double, and what are the precisions that are associated to those floats and doubles. Okay, and then we move on to the characters, which are which represents single characters. Okay, the type that we or the keyword that we use to characterize the characters are it is char or char. Okay, and then we have Boolean types. So these are all Boolean is kind of like a special type which represents either true or false. Okay, so let us see each type like integers, floating point characters, and Boolean separately. Okay, in the sense like let us understand what are they. Okay, like by, chart, int, all those things. Okay, so before that, let us see what do we do with these primitive data types. Okay, why do we call these as primitive data types? Data types. Okay, they are actually built into your Java language itself. Okay, they come. These are the data types which come with your Java language. They are built into your language itself. That is why they are called the primitive data types. You can't kind of like create primitive data types on your own. Okay, user-defined data types that you create using classes, right? They are user-defined data types. Similar to that one, you can't create these primitive data types. Okay, that is why they are called as primitive data types. Okay, so what can you do with these primitive data types? So like you can use these primitive data types as is, in the sense like as I have mentioned, int I is equal to 10. You can use it just like that. Okay, or you can create something called as arrays. Arrays are nothing but set of I mean they are used, or you can say that they are containers for use for storing multiple values of same type. Okay, they hold multiple values of same type, be it either integers or floating point numbers or characters or booleans. Okay, they hold multiple values, not single values. Here, int is a single int, the variable that you declare with a particular primitive data type. For example, int. Here I have declared int I, right? That can hold only one value, but arrays can hold multiple values of same data type. For example, if you declare an array of int, okay, it can hold multiple values of type int. So we give one particular name for holding multiple values. Okay, that is why they are we say like it uses a single name to hold multiple values of same type. Okay, or they can be used to create user-defined data types. That is our classes. Okay, we have seen okay, we will see. Okay, so these are basically used for all these things. You can directly use them like we did in our two simple programs. In our main methods, we declared a couple of variables and then try to print them, right? Like that, it is like we can use it directly as is, or we can use these primitive data types to form complex data types, which are your objects. Okay, so arrays are also called as objects. Arrays are also objects in Java. That is why you have two different types of data types. One is primitive as well as complex. So as we discussed, these form the basis for all the data types that you would require in your Java programming language. In any program or in any application, however big that particular application is, you would need these primitive data types to construct whatever the kind of data type that you require in your for your application. Okay. Okay. Let us move on to the integers. So as we discussed, integers defines whole numbers, or they are used for defining whole numbers, and we are it has four Java defines four different integer types. That is byte, int, byte, short, int, and long variables. I mean the data types. So in Java, in C, okay. So it is just a reference. In C, C++, okay, there are something called as signed numbers and unsigned numbers. Okay, so what do we mean by signed here? So whether signed is nothing but it is either a positive number or a negative number. Okay, so you can have a signed number or unsigned number. Unsigned number is your positive numbers only. You can consider that as positive number. Okay, by default they are positive numbers. But here in Java, all the numbers, whether it is integers or floating point numbers, okay, integers or floating point numbers, they are signed numbers. Okay, they are signed numbers means if you don't specify whether it is a negative number or positive number, then it, by default it will be a positive number. Okay, if you specify, you can specify negative also. There is no concept like signed or unsigned as it is there in your C, C++. That is why it is called as all the numbers specifically are signed numbers. We will see how what exactly that means. So let's move on to these individual integers. Okay, so we have we saw like we have 4 different integer types, right? That is byte, short, int, and long. Okay, so byte, as we know, 8 bits is 1 byte. So this particular byte, right? Byte int data type, it occupies 8 bits of memory. Okay, it occupies 8 bits of memory. When you declare a byte variable, okay, when you declare a byte variable, it actually occupies 8 bits of memory in your physical memory. Okay, so that is what the size means. It actually requires 8 bits of memory or 1 byte of memory to store a value of type byte. Okay, the range specifies what is the minimum or the boundary of a particular values that you can store in your data type, that particular data type. Okay, here the size of byte is 8 bits and the range or the number, the minimum number that you can store a byte variable that you have declared is -128. Okay, and the maximum value that you can store in a byte variable is 127. Okay, similar to that one. So where exactly do you use this particular byte data type? So as like whenever you deal with raw data, say for example your image files, if you want to process some image files or some other video files or something like that. Okay, or if for example you want to download some files from internet. Okay, all those things, whenever you need to kind of like process your raw binary data in zeros and ones, that is when you use your byte data type. Or we will see in our IO class, that is input output class, like to read data in something called as streams. Okay, it can be network stream or a stream which is connected to your file to read data from either network or from your file. Okay, that is where these byte data types come in handy. Yeah, yeah, Mohammed. Mohammed is asking a question. Can we store 130 in byte? That's an interesting question. I thought we will discuss this in after the class. Okay, in the practical session, I will show you what exactly happens when you exceed a particular range. When you exceed the range, okay, what exactly happens? So, next let's move on to the short data type, integer data type. So here it's a signed. Here it's a signed 16-bit integer type. Okay, that means whenever you declare a variable, okay, of type short, that particular value occupies 16 bit of memory in your physical memory. Okay, it requires 16 bits to store a value of type short. Okay. Similarly, we have a range 32,768 minus 32,768 is the minimum value that you can store, and 32,767 is the maximum value that you can store in a short. Okay. So it is a, I mean, we seldom see that we use short in our programming. Okay, in the, when we are using Java. Okay, that is why it is least used data type in Java. Okay, integer data type. So next is our int data type. So as you know, like the short, you can declare variables of type short using the keyword short. Okay. That is where, I mean, the heading that shows right here, that is the keyword that we use to declare a variable of particular type. Okay, so int is a data type that is of 32-bit long. Okay, it occupies 32 bits for storing value of type int. So Java requires 32 bits of memory to store a value of type integer. Okay. So the range you can see here. Okay. So it's like 2 billion, approximately 2 billion, minus 2 billion to plus 2 billion. Okay. That is the range. Again, we will see what exactly happens when we exceed the range of this particular data types. Okay. Similar to that one, we have long data type. That is, as usual, it takes it is the double of whatever the int takes. Okay, int data type takes. So the range is this much, and whenever you by default integers are int of type int in Java. Okay, so if you want to specify that particular, if you want to declare a long variable, you have to qualify that as or suffix the value with either lowercase l or uppercase l. Okay, otherwise it will show error. Okay, so this is the range that is the value that we can store in our long variable, or we can the particular variable that you declared as a long. Okay. Let's move on to the floating point types. So did you all understand what exactly is the size of each data type? Like we have seen byte, it's 8, and short, it takes double of that is 16. Okay, int takes double of short, that is 32, and long takes double of int, that is 64. Okay, these are, it is like you can assume you can assume those things like this, like you have a memory with 32-bit long. This is for, I'm just explaining for the integer. Okay, this is for float that is explained here. For integer, this is it starts with 0 to 31, so 32 bits, right? This is how, or this is the size, this is the memory size that is taken for integer. Just explaining this for integer. Okay, don't get confused with the float and the integer. So whenever you see 8 bits, you can consider like these are the 8 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for byte, it takes this 8 bits. For short, it takes 16 bits, and 32 bits for integer. Okay, you can assume like this, 32 bits like this. Okay, that is for explanation for the integer data type. So let's move on to the floating data types. So as you know, floating point data types are used for representing your real numbers or decimal numbers or fractional numbers, which will have two things. One is your whole number component, and then a fractional component separated by a decimal point, right? You can either specify them as a standard way, like with the decimal points, or scientific way, like specified in the slide. Okay, so float takes 32 bits and double takes 64 bits. So the default, if you specify any value, or if something comes as a floating point value, the default will be your double. Okay, if you want to specify float, you have to qualify that as f, or prefix the or suffix the value with f. Okay, this is where I am highlighting. Okay, so as we know, like it takes it, this is also a sign, that is very important to note. This is also a sign, and it takes 32 bits to store a particular float value. Okay, so how exactly these values, like why all these values are called as numbers, are called as signed values. Okay, so say for example, assume this is a 32-bit location where you can store one 32-bit integer or float. Okay, I'm just taking either float or integer, that is int. Okay, so you know that float takes 32 bits as well as int takes 32 bits. Okay, so the rightmost bit, the one which I am pointing, is called least significant bit. Okay, this is called as least significant bit. In electronics, we call it as LSB. Okay, least significant bit, and the leftmost bit is called as most significant bit. Okay, MSB. Okay, so the values, actual values that are used for storing your particular value of type. For example, the slide where I am showing this 31 bits, 0 to 31 bits are used to store the actual value of your integer, or as I have shown here, 8 bits are used for your exponent, and then 23 bits are used for your fractional part for floats. Okay, but the most significant bit is used for sign. It is used to represent sign. Okay, so if that most significant bit is 0, if the most significant bit is 0, it means the number is positive number. Okay, if the most significant bit is 0, it means it's a positive number, and if the most significant bit is 1, then this number is the number which is represented in binary, that represents negative number. Okay, so whenever you are storing a value, or number, okay, specifically the numbers in Java, as we mentioned, they are all signed. Okay, the most significant bit is always reserved for specifying the sign of a number. Okay, in case of byte, the 7th bit, 0, 1, 2, 3, 4, 5, 6, 7, 7th bit will be used for representing your sign. In short, the 15th bit will be used for storing your sign. In int, as I am showing here, the 31st bit is used for storing your sign, and for long, the 63rd, okay, the bit is used for storing your sign. Similarly, in float also, the most significant bit is used for sign. Then 30 to 23 bits are used for your exponent part. Okay, so this is exponent part, right? So this part, and then the fractional part, right? That is used for the bits like 22 to 0 bits are used for using your fractional part. Okay, whatever the fractions that you see here. Okay, so double, as the name itself suggests, it's a double of what float is. Okay, so this is a 64-bit floating point type. It requires 64 bits to store a particular value of type double. Okay, whenever you are trying to store a value of double, it takes 64 bits. Okay, So as we explained in our float, the most significant bit, that is the 63, the bit 63 is used for your sign, and here 11 bits are used for your exponent part, and 52 bits, approximately double the precision of your float. Here here we see 23 bits, right? Approximately double of this bits is used for storing your fractional part of double. Okay, the decimal or the fractional component of your decimal or real numbers. Okay, that is why floats are called single precision and doubles are called double precision floating point data types. Okay, so you can declare a variable of double using the keyword double d and 200 as 200.00. As we have mentioned, the default value is double for floating point in Java is double. So that's why we don't kind of like qualify with the D or capital D, as we qualify for float as F or capital F in floats. Okay, you can do it, but that is optional. Okay, for example, if you want to declare the same thing, you can declare it as 200.00 D, either small case or uppercase, but that is not required because the double is the default floating point in Java. Okay, so let's move on to the characters. So it is I mean, whenever you declare a character, it takes 16 bit, as we saw in other data types like byte, short, int, long, float, and double. This, whenever you declare a character, it takes 16 bit. Okay, so these are represented as something called as Unicode characters. Okay, what does this Unicode characters represent? It is nothing but a set of all characters which are like, which you can find in all the languages which have literature, right? Like literature, like English, 26 characters are there. Okay, so if you take some other language, they will have their own characters. Whenever right, so whatever the languages that you can or whatever the languages that are there, all the characters that you can represent are that you can represent it using this 16-bit Unicode character set. Okay, that you can put it in. Okay, whatever the characters that you can think of, you can find in that particular character set. That is what is Unicode character set of characters which defines all the characters that you can imagine is nothing but your Unicode character set. Okay, like we have ASCII character set, all those things. So next we have Boolean. So we got introduced to this particular data type in our one of the previous sessions. So it is nothing but a logical data type. Okay, you used to store logical values like we saw, right? Either true or false. Okay, it is used. The size of Boolean is just 1 bit. Okay, 1 bit, but the values that you can store is true or false, not 0 or 1. It is true or false. Okay, so as we have seen, these are kind of like whenever you use logical or relational operators, like in one of the sessions we saw, right? Less than, greater than, equal to, all those things. Whenever you are using those logical operators with the logical operators with the operands, they return the expressions that contain these logical operators and operands return these Boolean types. Okay, that is where you use these Boolean types, or you use these relational operators to form conditional expressions or logical expressions in your control statements to control the flow of your execution. Okay, like we saw in our if and for loops, right? So let us see what are these literals. Okay, so literals are nothing but the actual values of a particular data type. For example, if you ask integer literals, these are the actual values, right? You can say like, you can consider them as constants. Okay, they are the actual values. They are not the variables. They are the actual values that you store in your variables. Okay, or you can consider by, I mean, if you want to think of it as a constant, they are actually the literals. Okay, so as you can see, integer literals contain whatever the integer values that you can think of, they become literals of type integer, and floating points, floating floating point values, what are the floating point values that you think, and character literals similarly, they are enclosed within single quotes. Okay, like we enclose double strings in double quotes, we enclose those things in single quotes, that is characters. And Boolean literal, either true or false. Okay. Next let us try to uh, see some examples. Like one of you have asked one question, right? So what happens when we try to exceed the range? Okay. Okay. So one of the other uses of these data types is you can use them to declare variables, okay, of any particular data type. Okay. So we have seen that particular, right, in one of our sessions. Whenever you declare a variable, variable is nothing but a name given to a memory location in your physical memory. Okay. So how many bits of memory is needed for a particular variable is determined by the data type that you declare for that particular variable while declaring the variable. Okay, please interrupt me if something is confusing. Okay, so what I'm telling is any variable, okay, that you declare must be associated with the data type. Okay, so why do you associate data type to a variable? We know that variable is just a name given to your memory location. Okay, so when you want to give a name to a memory location, how the Java language or your compiler or when compiling, it knows that these are the set of bytes that I need to kind of like look into to get the actual value, exact value what we have stored. Okay, that exactly is determined by your data type. Okay, that is why any variable must be associated with your data type. Okay, so let us see, we have seen like we can, these are the primitive data types which we can use it as is, right? So we will use to declare some simple primitive data types like int I is equal to some 10. Okay, this is how we declare a variable. Okay, so we can use as is, we can use just the keywords that are Java keywords for this declaring these data types as int, byte, all those things as is to declare variables of particular data type. Okay, and similarly byte b is equal to 10. Okay, but what is the difference? We can store 10 in b as well as in I, right? Same thing. I have stored both 10 in either I or b. Okay, so what is the difference? Byte b is equal to 127. B1 is equal to 127. Okay. Say for example, I need a value which is greater than 127. Can we store it in byte? Can you all see what exactly is happening? Let us try to run this program. Okay. Are you all able to see my the result of this particular execution? When I try to run, it is saying unresolved compilation problem. Okay, this is a compile, as we discussed at the beginning of this session. Any data type mismatches are considered as compile time errors, right? Any data type mismatches are considered as compile time errors. That is why we have to resolve this compile time issues before we get our class files, before your compilation is successful. Okay, so how do you make this one? Just reduce by one value, it compiles. Okay, you don't get anything, any errors. That means you got your .class file corresponding to this particular data type test class. Okay, so this is what happens when you try to exceed a specific range. Okay, now I can't store 128 in your byte. So what about negative value? Can I store it? Yeah. So the range is from minus 128 to plus 127. In between, whatever the value you want, you can store it in byte. Say for example, yeah, we have seen 127, right? Say 10 also we have seen 49. Whatever the value you want, you can store it. Okay. But when it comes to greater than 128, you need a different data type. Okay, you need a different data type. So we can use short. Okay, so it is not showing any error. So whenever you need a value which is bigger, you go for corresponding kind of data type. Okay, but that's what bytes. As far as the usage goes, the most commonly used integer data type is int, which is of type 32. 32, I mean, which takes 32 bits of your memory, and then when you want to process raw data. Okay, so when you want to process, as we discussed, when we want to process raw data in bits and in bits, bytes, you want to process, that time we go for byte data type. Okay, when we need very large numbers, then we go for long. Okay, so how do you declare variable of type long? L is equal to 123, or you can make it as capital L, or you can prefix suffix at L. You declare a variable, and you can use assignment operator with a value to assign a particular value to your variable. Okay. Similarly, we can declare variable of type float. F is equal to 10.0 F double Okay, are you able to see this particular error? Cannot convert from double to float. Okay, so what we have to do is we have to suffix floats with the F. Then this particular error will get corrected. Okay, so either you can declare a variable and assign a value of type double to like 12.00 like this, because that is how That is the default data type, floating point data type for Java. Okay, or you can suffix it with either D or capital D. Okay, similarly, you can do that here with capital F. Okay, either lowercase or uppercases are allowed. Okay, but in case of double, that is not mandatory, but for float that is mandatory. Okay, so let us see for characters. So you use the keyword char for character. C is equal to C. Okay, you cannot put multiple characters within single quotes. Okay, it shows error because this will become string. Okay, so you can only store a single character in a char variable. Okay, similarly, Boolean B is equal to, you cannot store 0. Okay, or 1. Okay, that is an error. So what value you can store? True or okay, other than these two values, you cannot store any other value in variables declared of type Boolean. Yeah, I'm looking at the questions that you have, that you people are asking. Okay. Okay, Mohammed is asking, is there any need to specify with letters B, S, I, D at the end of integer values stored in a variable like we specify in float values? No, so it is not mandatory. Okay, here, see here, I have not, okay, let us try I for I you are telling, right? See here. So that is not how you do for integers. Okay, that is int, byte, float and short, right? You don't do those things. Even here, it won't show any error. That is not mandatory. Okay, to give, no, it is not it's not a question of mandatory or something. For long, that is not mandatory, but for short, it is not allowed at all. Okay, say for example, if I want to try I, that will become error. Okay, if I want to type B, I am assuming like this is how you, this is what you meant when you said the BSID. Okay. Okay. So here is the question. I think let me post it to all so that they also understand the question. Okay, this is the question Mohammed asked. So when he said BSID, he is referring to byte, short, int, and long. Okay, so probably you got confused with D with L. Okay, either you can specify with L or L. Okay, smaller this one. Okay, so that is not. I mean, it is for at least for int, byte, short, it is not allowed. Character using the suffix, character suffix is not at all allowed. But for long, you can use it. Okay, it's optional. But in case of float, that is mandatory. As we saw, if you remove this particular, it clearly says you can't convert the value from double to float. Okay, so you have to suffix it with the value. You have to suffix the value with f. Okay, and in case of double, you can use D uppercase or lowercase, but that is optional. Okay, as you can see here. Okay, so how do you use these values? Okay, so let us see. I will just give a brief or just high level view of creating a complex data type with these primitive data types. Okay. Here we don't have public static void main. Okay, we will by default all these we will see what is this private. Okay, all the data types or all the members which are not methods or functions should be private. Okay, that is by default, or that is the recommended way of best practice of writing code in Java. Okay, private int I, private double D, private char C. Yeah, it is a 16-bit, right? It is a 16-bit. Whatever the characters, it is the range you can't tell. Okay, so here is another question. So we have, it's an interesting question. Like we have not like it takes 16-bit. We specified that it takes 16-bit to store a particular character in Java. So what is the range? Yeah, we saw like for short it takes 16-bit, but there is a range associated with it, some 32,000 something, right? Some 200 something value. Okay, but what is the range that you can think of for characters? Can you think? Can anyone think and tell me what is the range that you can think of for characters? Can anyone think of and let me know? Yeah, that is correct, Mohammed. Yeah, 1 byte, you can say 1 byte, but whole of 2 bytes are used for storing your character. Okay, but there is nothing like range associated to your character data type. Okay, because you are not storing a value inside that particular character, right? You are storing characters. You can say like 2 power 16. Okay, that gives 65,000 some odd value, 65,535 values. Okay, that again gets converted into whatever the value that you can, whatever the character that you can think of. Okay, so whatever the value that you can store is 0 to 65,535, but you are storing a particular value. Okay, but what exactly internally you can say like it is in the zeros and ones only, right? That you can convert it into binary and say like this is the value of or this value whole number that is stored in your character data type, but actually what it represents a character, right? Yeah, correct. That is that's what that is correct, Mohammed. Yeah, whatever the value that you store internally, it is represented as zeros and ones only, and when you try to convert it into your decimal whole number, that you can say like one of the from 0 to 65,535. Okay, but actually we are storing a character. So what is the range of those characters? Those characters can be anything between 0 to 65,535, that will again fall into whatever the things that we saw. That is the one of the character that is defined within your Unicode character set. Did I answer your question, Mohammed? Okay, yeah. So this is what like primitive data types, and we have two types of data types, right? One is primitive, another one is your complex data types. So this is one of the examples where we can use primitive data types to form complex data types. So what we have done here, we have declared a class or defined a class with name complex data type that has these primitive data types. Okay, so these primitive data types are used for defining your complex data type, which is called as we keep on mentioning, which is called as user defined data type. Okay, we define user defined data type with class keyword. Okay, so what is the like whenever you say I, it takes this particular number of bytes, that is 32 bits. 32 bits are 4 bytes of data. Okay, so if you consider 32 bits, it is actually 4 bytes, right? So it takes 4 bytes, but what about the complex data types? We will see what are these variables which are declared outside of your main method. Okay, outside of your main function, that is public static void main. We've seen earlier, right? We will see what are these variables which are declared outside of any method or any of or within your main method. Okay, these are called as instance variables. Okay, we will see what are these instance variables. But again, whenever you create an object of this particular data type or user defined data type or any class, each object will have its own copy of these instance variables, okay, for which you can assign different values. The values that are assigned to one particular instance variable of an object is different from the value that you can assign it to the other instance variable of another object. Okay, we will see all these things when we discuss classes and objects in one of the sessions. Okay, so what I want to tell here is we have used this primitive data type to define a complex data type, or we have defined a complex data type using this predefined or primitive data type given by Java to us. Okay, that is how you create your complex data type using primitive data type. For example, another example is class human. Okay, he will have string or okay int. Okay, you can go on adding these things. Okay, height. Okay, if you go on adding the data type, this human, okay, that itself becomes a particular human data type or user defined data type, which you can use it to represent a particular human. Okay, so that represents, for example, you take anyone, okay, whoever is attending the class, or you can take me. Okay, you can specify the name, first name of my first name, my last name, or the number of eyes that I have, what is my height, what is my weight. Okay, all those things you can specify, which actually represents an object Okay, my object, if you specify all those things, which actually like my object, okay, for one particular this thing. So similar to that one, like one particular object will have its own state, and those objects will have its own different states, like I have mentioned here. So those kinds of states for a particular data type, you can to store the values for those states, right? You can use these primitive data types, okay, for defining your complex data types. Okay. Yeah. So when you click on these warnings, right, you can see the value. If you can see, I'm not sure whether you can see. I will just read it out. Okay. When you click on, I mean, just place hover on your that warning message. It says the value of the field human dot height is not used. Okay. So if you specify, if you declare a variable, it expects that you use it. Okay, that is for your performance stuff. Okay, if you are not using it, just gives you a warning saying like you have unnecessarily declared that particular excuse me, declared that variable which is not required for this particular object. Okay, not only for human, it is showing that warning is showing for here also. For example, say I will put okay, still it shows warnings, right? And yeah, this is another question which was asked, that is okay, this is one question, and another one is this is another question. Okay, so I will try to explain this and close or wind up this session. Okay, so it is showing warning. Let me take one particular example. Value of I, okay, plus we are appending I. So you can see I have used I here in one of the statements. That's why it is that particular warning is gone. Okay, it simply shows you have declared something which you are not using it. So it's just a warning to us saying like just see whether you want to use that particular variable that you have declared. If you are not using, better not to waste memory. Okay, whenever you are declaring and assigning a value, you are using memory, right? So better delete it so that you can save memory. Okay, that's it. That is just a warning which implies that one. Okay, you are unnecessarily using memory. Why you want to use memory? Delete it, which is not required. That is the meaning of that one. Okay, and then the second question is class. Okay, I think I copy paste the same thing. Class human is object or a variable. Okay, so we will discuss all these things in class or object class when we discuss classes in depth. Okay, classes and what are objects. Okay, objects of a particular class, all those things. Just on a high level, this is the definition of your class. Okay, this actually is a code that actually represents your data type. Okay, similar to what Java language developers would have done for this int. Okay, forget about this part. Okay, they would have done some coding for declaring or predefining or for this particular primitive data type, right? For example, okay, int is a keyword which represents 32 bits of memory for storing whole numbers, right? So this is a keyword of Java. What does that keyword mean? So it has a special meaning in Java. You can't use that for declaring any variable. For example, can you do this? No, you can't do that because it says syntax error in token on token int, invalid variable declared or declarator ID. Okay, you can't use those keywords as your identifiers, which are used for naming different things, your functions, your variables, all those things, your classes, all those things, right? Okay. Yeah, we can store those values. Yeah, Mohammed, I'll get back to you. Okay. So we can't use these keywords in as identifiers for any of the things like naming your classes, naming your methods, functions, or your variables. Okay. So for them to become some keyword, you must have or the Java language developers, not the Java programmers, Java language developers, those who develop Java, right? Java itself, the language itself, right? So they must have given some code for this particular keywords. Means int means as soon as you say int, it is 32 bits. Okay, it occupies 4 bytes of your memory. So for that to happen, the Java language developers might have written some code. Okay, that is what is similar to what you have written here. Okay, and when you say I is a variable of type int. Int is a data type, but I is a variable of type int. Okay, similar to that one, complex data type is a data type. Okay, you can declare a variable of complex data type, like we have declared int in is equal to 10, like this. Okay. So this becomes an object. Without this is just a reference. Okay, this is just a reference or a variable. You can call it as a variable. Okay, so this is a variable. This is a data type. Okay, this variable is of type complex data type, or you can say XYZ. Okay, XYZ is a variable of type complex data type, similar to IN is of variable int data type. Okay. Yeah, Pragati, did you get it? Did I answer your question? Hope I answered your question. Okay. Another question is, can we store values in these values? This is the question. Okay. Can we store values in decimal, octal, or hexadecimal number system in a integer variable? And let us see whether we can do it or not. Okay. Int x is equal to So you use or you prefix, okay, 0x for your hexadecimal numbers. So for by default your this thing, okay, let us try to print the value. Okay, this is the hexadecimal value that you are storing here. So when you prefix 0x, that means it's a hexadecimal value. And normally, like these are decimal numbers, right? And give me a second. So whenever you prefix a particular number, decimal number with the 0x, okay, so that will be your hexadecimal number. And whenever you prefix it with the 0, that will become your octal number. Okay, so in decimal 1, 2, 3, the octal number 1, 2, 3 is equivalent to 83 in decimal, and in hexadecimal, if it is 1, 2, 3, 123, it is 291 in decimal. Okay, that's how you represent in decimal, octal, and hexadecimal numbers. Okay, you can store hexadecimal number this way just by prefixing 0x to a number, and octal by prefixing 0. Okay. Is that fine, Mohammed? Okay. So are there any questions? Normally, we will not use these octals and hexadecimals in our normal programming. So we rarely use it. It is not like we won't use it at all. Okay. So something like, say for example, when you are trying to work on some kind of like you are trying to develop some application which actually deals with say for example you are writing a kit for 8085 microprocessor itself. Okay, you are writing a UI which simulates the like kind of like you can write a assembly level program and input it using your application which you have written, right? In such cases, you might you may use your octal and hexadecimal format for these numbers, but very rarely I have seen like very rarely we'll use these number systems. Okay. Okay. Okay, this is one question. Yeah, correct. Dollars are used. Okay, so this is another question. So we have range of 32,767 to 768 in short integer data type, right? Yeah. Is there a wastage of memory size if we store a low value in a variable? That is one. Why do we write private or public before the keywords at the time of variable initialization? Okay, it's not initialization. We are just declaring variables. Okay, you can initiate. That is what initialization also. You declare and initialize that particular variable in this one. Okay, we will see the second part, right, Mohammed? So Mohammed has asked this question. The second part, why do we use private or public keywords for variables? Okay, we will see why do we use that. So if you see here, if I write private, right, it shows errors. Okay, it shows errors, compilation error. We will see why these things, or even if you write, okay, it shows errors. We will see why this shows errors, and similarly, if you see here, this is a valid statement, right? This is a valid statement. Okay, we will see why we use that one in our future sessions. Okay, let us not get confused with all these things in each and every session. Okay, so when we deal with that particular topic, right, we will clearly explain what exactly each and everything means and why exactly do you use those keywords. Okay, another one. The first question is: we have a range of these things for short. Is there any wastage of memory size if we store a low value variable? Okay. So what you meant was, yeah, I am saving 10 in int, which I can store it in byte itself, right? So when I am using the int for storing 10, is there any memory wastage? Is there memory wastage? So if you consider, I mean, it again depends on what exactly you are trying to achieve with the data type that you are using. The data type is not just the size of the memory that you are trying to use. Okay, it is not just the data type that you are trying to use it. It also depends on in which context you are trying to use it. Okay, in the sense, in some situations where you use byte, right, they automatically get converted into int based on the context of that particular either expression or variable where you are using that. Okay, so in that way, if you say like I am storing 10 in int, and if int takes 32 bits of memory, of course you can say like it is a wastage of memory. But again, as I said, It is the context in which you are trying to use it. Okay, then say for example, when you are trying to use like streams, right? When you are trying to connect and process your raw data, this byte may be useful. It again, as I told you, it again depends on where you exactly use these data types. Okay. Yeah. Did that answer your question, Mohammed? Okay. Yeah. Thanks. Let's stop this session at this point. Okay. We'll meet tomorrow at the same time. Okay. Thanks everyone. Thanks a lot for attending that session. We'll meet tomorrow at same time, 8 p.m. CT. Okay. Bye. Yeah. Have a great evening to you all. Thank you very much. Bye bye.